Okay, I'm going to record this in chunks because this program doesn't like long videos, so there's probably going to be 4 or 5 parts. So here's part 1. Graph each function. So I didn't give you graph paper, but on the final you would have a graph and you would have to plot the vertex, the zeros, and 2 other points. I'm more interested in how is each graph a translation of x squared. So this goes left 2, down 4. So I know the vertex is -2, -4, and it's just a regular width, and it goes like that. Identify the vertex and axis of symmetry of the function. So the vertex is -3, -2, and the axis of symmetry is x equals -3. If you forget the x equals, it's wrong. This parabola has a vertex, also passes through the point. So you have to know the vertex form of a quadratic. Then you have to plug in everything you know. You know the y value is -2. You don't know a. You know the x value is 9. H is 8. K is -4. Some simple math here. 9 minus 8 is 1. Squared is 1. A minus 4. Add 4 to both sides. A is 2. So your function is y equals 2 times x minus 8 squared minus 4. Use the vertex form. So again, the vertex here is 1, 2, 3, 2. And it goes through the point 2, 5. So we're going to do the same thing we did here. This is the point, this is the vertex. So 5 equals a times x, which is 2, minus 3 squared plus 2. 5 equals, again, 1a. -1 squared is 1. So a equals 3. The vertex form is y equals 3 times x minus 3 squared plus 2. Gotta know vertex form. Okay, axis of symmetry, -b over 2a, -16 over 4 is -4. Vertex is -4, comma, 1632 minus 64 is -32, minus 12 is -44. I'm just going to check that real quick. 16 times 2 plus 16 times -4. Yep. So, axis of symmetry, x equals -4, vertex, -4, -44. Vertex form, well, first you need the axis of symmetry, which is -1. Then you need to plug it in to find the y value of the vertex. 1 minus 2 is -1, minus 2 is -3. So then you have y equals, the a here is the same as your a here, so it's just 1. X plus 1 squared minus 3. Factor, oh boy, we better be able to factor by now. Here I would take out a -1 first, and then I would go from there. Just my personal preference, I don't like to factor with a leading coefficient that's negative. If you had something along the lines of -x minus 10 times x minus 4, fine. Or x plus 10 times -x plus 4, fine. This is just my preferred way of doing it. Finally, down here I have a GCF of 5x. When I take it out, I have 2x plus 5 left over. More factoring fun. Look at how exciting this is. I'm going to take out a GCF of 4, leaving me with x squared plus 9x plus 18. So that can go into x plus 6 times x plus 3. Here I'm going to take out a -5 because I don't like a negative leading coefficient, leaving me with x squared plus x minus 12. So that factors into x plus 4 times x minus 3. We have no GCF here, so we just have to do trial and error. The only way to get 5x squared is 5x and x. 16, I'm going to try 4 and 4, and then I'll try 8 and 2. So if I put a 4 here and a 4 here, check the OI. Outside is 20, inside is 4. That's not going to give me 42. So let's try 8 and 2. Outside is 40, inside is 2. That gives me 42. I'm done. 5x plus 2 times x plus 8. This is just difference of squares, x plus 6, x minus 6. No GCF here. I'm going to try 4x and 3 and 3. Check the OI. Negative 12 and negative 12 is negative 24. Difference of perfect squares again. And we're done. Let's pause there and see if it works. Video pause.